Hello friends, welcome. Today we'll be doing a question related to swing equation. And the question is, a generator is given to us which is 500 MVA and it is 6 pole and 60 Hertz. Okay, and the kinetic energy which is stored in the rotor is 200 megajoules. And the input to this machine is 25 megawatt and it develops a power of 22.5 megawatt. Okay, then he is asking what is the acceleration in electrical radians per second square. Okay, so please take a note of this unit, and we have to get our answer in electrical radians per second square. Okay, so let us see how to proceed for this problem. So this can be done very easily with the help of swing equation. So I write the swing equation and then I'll explain. So the swing equation is 2h over omega s 2 square delta over dt square is equal to P mechanical per unit minus P electrical per unit. Okay, so here the mechanical input is 25 megawatt and the output power is only 22.5 megawatt. So the rotor is going to accelerate. Okay, so we have to find the value of d square delta over dt square. Okay, this is what we need to find. Okay, so if we are able to find all the other values, definitely this will be known to us. Okay, so let us calculate them one by one. So let us first find h. So h is given as kinetic energy stored in the rotor divided by the rating of the generator. Okay, rating of generator. So here you can say that h is equal to kinetic energy stored is 200 megajoules over 500 mega volt amperes is the rating. Okay, so here my h is going to be 0.4. If I calculate this, 0.4 seconds, the unit is seconds. Now h is known. Now let us calculate omega s. Omega s is, okay, 2 pi into 60. Okay, so here you have to be very careful. This 2 pi why I have written is because it is in electrical radians. Okay, if it was in electrical degrees I would replace 2 pi with 360. Okay, so this thing you have to keep in your mind. So if you write this comes up to be 120 pi. Now we know everything about this term 2h over omega s. Okay, now we are left with this P mechanical per unit and P electrical per unit. Okay, how to calculate this? So we have P mechanical with us, okay, which is 25 megawatt, and P electrical is also with us, that is 22.5 megawatt. Okay, these two things are given to us. Now what you can do is first you can subtract these two. So mechanical minus P electrical is going to be 25 minus 22.5. So this is going to be 2.5 megawatt. Okay, now this P mechanical minus P electrical is known to me. I will write it again here. P mechanical minus P electrical is 25 minus 22.5, which is going to be 2.5 megawatt. If I want to calculate it per unit, so I have to divide by the base. Okay, so P mechanical per unit minus P electrical per unit is going to be 2.5 divided by 500. Okay, 500 is the rating of the generator. Okay, so this is my P mechanical per unit minus P electrical per unit. Okay, so now I have everything, okay, with me, and now I can proceed to calculate angular acceleration. Okay, so again I'll write the equation 2h over omega s into d square delta over dt square is equal to P mechanical per unit minus P electrical per unit. Okay, so you now have the value of h, which is 0.4. Omega s is also given 120 pi. Okay, so you can substitute all these values here, and what we get is 2 into 0.4 over 120 pi into d square delta over dt squared is equal to P mechanical minus P mechanical per unit minus P electrical per unit value is 2.5 divided by 500. Okay, now from here d square delta over dt square is equal to 120 pi into 2.5 divided by 2 into 0.4 into 500, and this comes out to be 2.356 electrical radians per second square. Okay, so the answer to this question is 2.356 electrical radians per second square. Okay, so this is how you can proceed for these kinds of problem. Okay, so thanks for watching.